So during next 10 minutes, I would like to present you our results on efficiency studies of fish downstream passage solutions presented by Laurent for Atlantic salmon smolts and European silver eel at small and medium-sized hydropower plants. In France, two main solutions recommended to protect downstream migrating fish are horizontally inclined racks and to-the-flow-oriented racks, both with low bar spacing between 20-25 millimeters associated to a bypass. The detailed criteria that I will not detail here are published or were published in the guideline of Dominique Couret and Michel Larigné in 2008. And several years later, many projects appeared, and it was a great opportunity for us to start efficiency studies for salmon smolts and silver eels. So the first study was performed in 2015 on Atlantic salmon smolts using RFID technology, and just briefly on the methodology. We targeted the fish with pit tags and release them upstream of the hydropower plant and detect the passages in the bypass with detection antenna. This technology doesn't allow to detect the passages through turbine. Also, we are not sure about the actually migrating fish, because some fish could swim upstream or be predated before migration. And so in this case, passage efficiency was computed only taking in account fish detected in the bypass divided by all released fish. Also, passage time is not an exact value, just an approximative value, because it's the moment between the time of release and the time where the fish was detected in the bypass. And of course, the release time is not maybe the best to start the migration, but we think that we are quite near of the reality. So our first study site was a small hydropower plant with an intake capacity near of 8 cubical meters, equipped with inclined rack with 2 bypass entrances and a total bypass discharge corresponding to 6.4% of hydropower plant discharge. You can see that we install the 2 antenna in the bypass. We follow also the passages through the fish pass, and we install 1 antenna in the bypass entrance, resulting in better efficiency. So we didn't use the data from this antenna. Here you can see our first results, and in average the passage efficiency was a little bit more than 80%. The passage time through the bypass was quite satisfactory, because in the majority of cases the fish passed in less than 2 hours. A very low number of fish used the fish pass for downstream migration, only near of 4%, and finally near of 16% was undetected and considered as passage through turbine. Next year, we studied 3 other sites with the same methodology, and 2 sites were equipped with inclined racks, 1 with oriented rack, and you can see that our passage efficiency results are quite similar to previous one. We are between 80 and near 90% of fish successfully protected, and the passage time was quite similar also. The majority of fish passed in less than 1, 2, or 3 hours, depending on the site. Since 2017, we started to study larger sites using radio telemetry and on Atlantic salmon smolts, but also silver eels. This technology allowed us to detect exactly the passages through turbine and also the fish, available fish actually passing through the fish downstream passage solution. So we could compute exactly passage efficiency and exactly passage time. To reduce the number of fish necessary for the study, we choose 5 hydropower plants, all equipped with fish downstream passage solutions, all in the same river reach. 4 sites are equipped with incline racks. The one equipped with oriented rack, this one is a little bit particular because in addition to the bypass, we have just here a flashing gate which opens when the river water level increased, and during the study the flashing gate was opening quite well. And so you will see that I separated the results between these 2 passage possible ways. So quickly on salmons, the study was conducted during 2 years, hydrologically very different years. It was very nice because we could test the fish passage solutions under different hydrological conditions. And you can see that passage efficiencies are very satisfactory. We are between near 80 to 100%. It seems that the passage efficiency during low flow events are a little bit lower, but there is no significant differences. And the passage time is very quick. In the majority of cases, just some minutes. Here a little bit more, but it's because the site is bigger in comparison to others. Further analysis allowed us to detect the influence of bypass passage on the probability of successful bypass passage and fish hesitation. And finally, we could conclude that the design bypass discharge, which is between 3 and 5% of hydropower discharge, ensures high passage efficiencies and low probability of fish hesitation. Quickly on results for eels. Once again, the study was conducted during 2 years, hydrologically very different. And you can see that we achieve a very high passage efficiency, almost 100% or near of 100. The passage time is once again very short, some minutes in the majority of cases. The last slide, just to show you all our results of passage efficiencies for salmon smolts and for silver eels. You can see that intra and inter variability in passage efficiency is quite narrow, and we can conclude that these fish downstream passage solutions for small and medium-sized hydropower plants is efficient tool for fish protection during the downstream migration. Here, just this graphic is just to compare with previous passage efficiencies on the same sites of former trash racks. When you can appreciate the ecological benefit you can achieve if we install this passage solution. So I would like to thank all our partners involved in the project, and I would like to thank you for your attention. If you have some question, don't hesitate to contact me by email. Thank you.